Hello, my name is Vaibhav and my colleague name is Hemanta Patil. We are the students of the ICAD Academy Faizpur district Jalgaon. Today we are going to explain you about a new concept which may be used to reduce the exhaust emissions of the vehicle like nitrogen oxide, hydrocarbon and carbon monoxide. So let's start with new one. I am simulating this on factory talk view. The name of my concept is study on vehicle pollution controlled by using zeolite beds. First, it is a screen of factory talk view. There are two buttons on the screen as shown, that is start and stop. Also, once a messaging strip is given which will makes you understand that what is going on system. The total system is divided in three parts. First the bypass line, second the system line, third is the subsystem line. First, the bypass line is directly joined between air filter and engine. Second, the system line consists of zeolite beds. These zeolite beds are coupled with stepper motor which rotates at 180 degree and changes the positions of the beds from Z1 and Z2. Zeolite has tendency to absorb nitrogen from air. Once Z1 is totally filled with nitrogen, then N2 sensor will sense it and send the signal to the ECU. Then ECU will command the motor to rotate. System line consists of a compressor 1 which is used to compress oxygen, rich air and store it into the oxygen tank. Oxygen tank has a level position sensor. Whenever it will sense if level is full, then it will send the signal to the ECU and ECU will command bypass line to close by shut down the bypass valve. System line consists of O2 tank, outlet valve, a carburetor which is used for doing proper mixture of air and fuel. Finally, the system line joined to the engine. Now subsystem line, it is start with zeolite bed which is positioned right to be extract the N2 from bed and making it clear. It will be done by compressor 2. Subsystem line consists of N2 tank where N2 will be stored. It consists of a valve 1 and provision to be bypassed N2 into the system line. Now come toward engine. Engine is provided with a temperature sensor because if we provide O2 rich air to engine, then it may result to increase in thermal efficiency as well as complete combustion, but also increase in temperature. So due to this it may cause pre-ignition, detonation, knocking. So to avoid this sensor will sense temperature and sends the signals to the ECU. So ECU will open the valve 1 and allows N2 to be mixed with the air for cooling purpose. Now let's start with simulation. First, the atmospheric air entered into the system. Foreign dust particles will trap into the filter. From filter, air will bypass to engine directly through the bypass line. Carburetor, which is a present and conventional method. Simultaneously, the air will pass through zeolite bed Z1 compressed by compressor 1 and O2 rich air will stored into the oxygen tank. When the tank gets filled with O2 rich air, then position level sensor will send the signal to the ECU and shut off the bypass valve. As you can see, the position level sensor get yellow, means it is activated, and ECU sends the command to the bypass valve to be shut down, so the bypass line gets red and air will pass to the system line to engine. When temperature of the engine get raised beyond a certain limit, the temperature sensor will sense and send the signal to the ECU. As you can see, the temperature sensor get yellow and it will send the signal to the ECU, so it will shut on the valve 1. So that's why the N2 from the N2 tank will get mixed off with the oxygen from the oxygen tank and it will finally send it to the engine. Thank you.